Hello everyone! Miss Anna is here to talk about a very interesting lesson in chemistry. Now, before we dive in, I want you to see this picture. What can you say about this figure? Yes, they are skydivers. Now, these skydivers are forming a pattern. Why do you think they're forming a pattern? Why do you think they're holding hands together? Exactly. Together, holding hands, these skydivers are a stable group. This is an analogy that can be seen on the stability of the compounds compared to the skydivers as they float in the air. Now, this is related to our topic for this day. They bond together to form a pattern. It is the same as compounds and they form a stable group. Now let's dig in deeper to our lesson for today. What are our learning objectives? The first is we need to identify the type of energy force between metals and nonmetals. Number two, we need to draw or learn how to draw the diagrams illustrating the force of attraction between metals and nonmetals. Number three, how do ionic compounds form? Actually, our main topic for this morning is ionic bonds. Now, let's take a look at this figure. Two atoms talking together. What do you think is the charge of the other atom and the charge of the other atom? Exactly. The other atom has a positive charge and the other atom has a negative charge. Now, the red color atom is about to lose an electron, and the golden color atom is about to gain the electron, or to get that electron coming from that other atom. So, what do you think are they going to do after talking? Exactly. They're trying to talk about transferring of the electron to the other atom. Now, always remember that opposite charges attract, positive and negative. Now, let's go deeper into our lesson. To understand what is ionic bonding. Now, let's have a short review about what is chemical bonding. Now, there are forces that hold groups of atoms together and make them function as a unit, and it is called bond. Atoms tend to reach more stable states at lower chemical potential energy levels by bonding with other atoms. When atoms react chemically by, always remember this one, losing or gaining or sharing electrons. Now, they form chemical bonds that hold atoms together. The electrostatic forces of attraction are formed when an electron transfer and electron sharing interactions happen. Now, let's have the concept of ionic bonds. Transfer of electrons between metals and nonmetals. Once again, ionic bonds, transfer of electrons between metals and nonmetals. Let's have an example. How do sodium and chlorine atoms bond together? Now, the first step is you need to know what is the atomic number of sodium, or if you have studied about the electron configuration of sodium, it will be easier for you to know how do sodium and chlorine atoms combine or bond together. So let's have a short review first of valence electrons. Electrons in the outermost energy level of an atom are known as valence electrons. Now if we're going to look at the orbitals of this atom sodium, we're going to look at the electron configuration 281. Now the valence electron here is 1. It has one valence electron, or it has one outermost electron in its shell. Now these electrons determine the kind of chemical bonds, if any, the atom can form. Now, studying valence electrons is very essential because it refers to the capacity to form the bonds. Now, since sodium has 11 protons, it has also 12 neutrons, and it has 11 electrons. Now, the atomic number is 11, and the atomic number is equal to the number of protons and electrons. Now, if you're going to look at the electron configuration, is 281. Now, we're going to talk about the octet rule. Bonding follows the octet rule, which states that the atoms of the elements form bonds so as to have 8 outer electrons. Take note of that. 8 outer electrons, or 8 valence electrons. Now, as you can see, sodium has one valence electron. Now, what are you going to do with this? So it seems like sodium atom as a neutral state, wherein it has 11 protons and 11 electrons and 12 neutrons, needs to lose one electron to make it stable. Now, for another atom, chlorine, as a chlorine as the other atom to be bonded by sodium, has 17 protons and 18 neutrons and 17 electrons. Now here, if you are going to look at the electron configuration of chlorine atom, it has 2, 8, and 7. If you're going to go back with the octet rule to achieve the stability of the atoms or of the compound, the valence electron of chlorine is 7, or the outermost electrons, it has 7. So it needs one more electron to achieve the stability of this atom or compound later on. What are they going to do is, they need to do like this. The sodium atom needs to lose one electron, or needs to transfer its one valence electron to the chlorine atom. Now, how do sodium ions form? The sodium atom has one electron in its outer shell. Now, this sodium atom is in neutral state. Now, when this sodium atom loses its one valence electron, it will become a sodium ion. So from sodium atom from the neutral state, and when it loses an electron, it will become a sodium ion. with a charge of 1 plus. Now, this chlorine atom has 7 electrons in its outer shell, so it needs 1 electron. So therefore, this chlorine atom in its neutral state, if it gains an electron to complete the outer shell, it will become a chlorine ion with a charge of 1 minus. Now, for this ionic bonding, it means the transfer of 1 electron from sodium atom to chlorine atom to become sodium chloride. Now, this bonding that happens from a metal and a non-metal is called ionic bonding. Always remember, ionic bonding is the transfer of electrons between a metal and a non-metal. And the best example for this one is the sodium chloride. So let's have a short recap or review of the ionic bonding, or how do sodium atom and chlorine atom bond together. Now, a sodium atom has 1 valence electron, and its electron configuration is 281. That means to say it has one extra valence electron, so it needs to lose or to transfer its 1 valence electron to form the stability or the stability of the atom. Now, chlorine atom, on the other hand, gains that electron coming from the sodium atom because its electron configuration is 287. Now, that 7 valence electrons needs one more electron to achieve that 8 valence electrons, thus forming the ionic bonding of the sodium chloride. Let's have another examples of ionic compounds. Now, when we say ionic compound, it generally consists of a metal and a non-metal. Now, always remember that the metal loses electrons and becomes cation, or a positively charged ion. On the other hand, the non-metal gains electron and becomes an anion, or a negatively charged ion. And through the forces of attraction between two opposite charges, an ionic compound is formed. An example of that is the sodium chloride compound. Now, sodium chloride is an ionic compound. Now, if we're going to look at the periodic table of elements, the zigzag part here of the periodic table of elements, you can see from boron, silicon, arsenic, tellurium, astatine. These parts onwards, you can use these elements to form the bonding of ionic bonding from metals and non-metals. Now, these colored green elements are non-metals. Now, normally, alkaline metals such as lithium, sodium, potassium, rubidium, cesium, and francium, you can use these metals to the other non-metals to bond to form an ionic bonding, such as sodium and chlorine. Now, what can you say about this picture? Yes, it is a table salt. Our next topic is about how solid sodium chloride is formed. Now, the chemical name of our common table salt is sodium chloride. When we say sodium chloride, solid sodium chloride. This is what we call the table salt. Now look at this picture. How does solid sodium chloride form? Try to look at the picture. Okay, this is the ionic crystal lattice of sodium chloride. Now, when billions of ions of sodium chloride bond together, form together, it will form a crystal lattice of sodium chloride. And the resulting ions come together due to the electrostatic attraction of these ions. Now, if you're going to look at the chemical formula of the sodium chloride, since the net charge is 0, the charge on each sodium ion is 1 plus, and the charge on each chloride ion is 1 minus. So it is NaCl. Now, drawing ionic compounds, we can also talk about the Lewis dot structure, but we are going to talk about the dots and crosses of electrons when drawing the ionic bonding diagrams. Now, for example, draw a diagram to show what happens to the electrons when a magnesium atom reacts with a chlorine atom. So, first step is, let's get the atomic number of magnesium, or let's look at how many protons and electrons does a magnesium have. So this magnesium atom has an electronic configuration of 282. The atomic number is 12. Now, therefore, it has 2 valence electrons. For chlorine atom, chlorine has 17 protons and 18 protons, and the electronic configuration of chlorine is 2, 8. Therefore, we need 2 chlorine atoms for us to be able to transfer the 2 valence electrons of magnesium. 1 valence electron of magnesium atom will be transferred to 1 chlorine atom, and another to 8. By the way, let's go back. The magnesium atom has an electronic configuration of 287. Therefore, it has 7 valence electrons. Now, to make it stable, it needs 1 more electron coming from magnesium. Now, the 2 valence electrons of magnesium will be transferred to 2 chlorine atoms. So 1 valence electron will be transferred to the chlorine atom, and another valence electron of magnesium atom will be transferred into chlorine atom to make it stable. Now, this will become magnesium chloride. Now, let's take the charges of magnesium chloride. So, the charge for magnesium atom is 2 plus, and the charge for the chloride ion is 2 minus. Therefore, the chemical formula of magnesium chloride is MgCl2. This one. 2 minus. Okay, magnesium ion is 2 plus, and the chloride ion is 2 minus. Now, if you're going to do the crisscross method, the magnesium chloride chemical formula is MgCl2. Now, let's have another ionic compound. Now, you're going to try your best how to show or draw a diagram how to show the bonding of these elements. First is magnesium and oxygen, like this one. Take note, magnesium and oxygen. Now, here magnesium has an atomic number of 12 and oxygen has an atomic number of 6. Therefore, oxygen needs 2 valence electrons. Magnesium ions have the formula of Mg2+, while oxide ions have the formula of O2-. The resulting compound is called magnesium oxide. Now, this is an example of burning a magnesium ribbon.
We're going to take a strip of magnesium and burn it in our Bunsen burner. We're going to use crucible tongs and hold the magnesium in the flame without directly looking. You never want to look directly at the burning magnesium. It's going to emit a very, very bright white light, and so you want to make sure you look away so that you don't damage your eyes or vision. So make sure you look away from the flame as magnesium burns. Have a watch glass close by, and you just let the magnesium oxide, which is the product being synthesized, the oxygen in the air will combine with the magnesium to create magnesium oxide. And it's going to become a white powder. It will drop onto your watch glass so that you're able to observe the product. So you have the watch glass. One word of caution, never drop the burning magnesium directly onto the watch glass. Hold it and just let it burn until it burns itself out. And it will crumble and the product will hit the watch glass. But if you actually drop a burning piece of magnesium onto the watch glass, you do risk breakage, so use caution. So again, this is synthesis, the burning of magnesium.
So again, this is synthesis, the burning of magnesium.
And now I can release it, and you can see how it just crumbles. And we have some magnesium oxide. That's why the crucible tongs are now white. Magnesium oxide is a very soft white substance. So that is an example of a synthesis reaction, the burning of magnesium.
So that is an example of a synthesis reaction, the burning of magnesium.
Now, the burning of magnesium ribbon is an example of the magnesium and oxygen ionic bonding. Now, as you can see, there was a chemical reaction happened when the magnesium ribbon was burned into that Bunsen burner, which means like there was an oxygen, and therefore it formed an ionic bonding because the magnesium ribbon and the oxygen reacted with each other, thus forming a magnesium oxide. So that compound is called magnesium oxide. Now we can have practice more. You can decide how many electrons are in the outer shell of each atom and mark them on. And you need to show how the electrons are transferred. And you need to show also how many electrons the ions now have, or the charge, on each ion. Now for the summary questions, you need to draw a diagram to show what happens to the electrons when a sodium atom reacts with a chlorine atom. What is ionic bond? Describe in your own words the structure of solid sodium chloride and explain why its formula is sodium NaCl. Explain why magnesium ion has a charge of 2+. The ions in magnesium oxide stay together. Magnesium chloride has no overall charge, and the formula of magnesium chloride is MgCl2. And for your homework, you need to enumerate at least 5 more examples of ionic compounds. And you do have your research mission. Now, before I will end this lesson, ionic bonding is the transfer of electrons between metals and nonmetals. Always remember that when an atom loses an electron and when an atom gains an electron, which are the general tendencies of an atom, they form ions. Sodium chloride is an example of an ionic compound because it forms with ionic bonding. Now, when sodium atom will lose its electron, it will form a sodium ion. When chlorine atom gains an electron, it will form a chlorine ion. Now, when they bond together, they will become sodium chloride, which is an example of ionic compound. We will further explain this lesson as we go on to our next lesson. So, have a nice day.